Welcome back, everybody. So, we're going to keep talking about systems of equations today, particularly how to choose the best method on how to solve systems of equations. So, just a quick recap. So, a system of equations is pretty much, particularly when we're talking about linear equations. So, if we have basic graph, pretty much, right, our x and y plane, and then we have two lines, in this case, two linear functions, because that's pretty much what we've been working on. And then the other part, if we have another line right here, in our system of equations, we're looking for a solution, which in this case would be that point of intersection. All right. So that's pretty much every single time. It's just a coordinate we're looking for. It's an x and a y. That's it. All right. And then we can do it graphically, right? You guys have the options of doing this in a graph, either using Desmos or another graphing calculator if you choose to. And then we also discussed pretty much the two basic algebraic methods. We discussed the equals, right? The equal values method, or also known as a substitution method. So you guys will see pretty much it's interchangeable right there. And then also we also talked about elimination. So that's another algebraic method on solving systems of equations. Now, now that you guys pretty much practice both of these methods, so it's always the best idea like which one are you going to choose when you're trying to tackle some of these problems. All right. So pretty much the first question you always want to ask yourselves is in which form is my linear function. So if you guys remember there's two types of forms when we graph, right? Our first form, the most basic one, is like the y equals mx plus b, which is also known as slope intercept form. And then the second one, which was our standard form, which was our ax plus by equals c. So remember, these are two basic forms of our linear functions, right? So if you guys want to graph a line, you can do either form and it should always work out for you. All right. So this is called the standard form. All right. So from there, we're pretty much so once we use both of these methods, equal values and elimination, right? As long as we can identify which form it is, we can use the quickest route to use either of these, right? So the equal values method, just a quick review again, the substitution method, it works best pretty much if you guys have both things equal to the same thing, meaning like if you have both r and pretty much y equals mx plus b. All right, so both of them, both lines are in the same form. In this case, which is uh, slope intercept form, right? Slope intercept, and then or the other case might be that one of them is already in slope intercept form, which could be like y equals mx plus b, and then your other equation might be in standard form. So it might be like ax plus by equals c, or maybe a combination, like a variation of that. It could be even like by, right, and ax plus c, something like that. For example, like there's a number in front of the y, or it might even be the ax plus by equals c, right? There's a number in front of the x. So it might be a little bit easier for you to solve using the equal values method, the substitution way, if we have it in either of those forms, right? Now, the other one, the elimination method, works a lot quicker if you have it already, both of them in standard form. So if both functions are in ax plus by equals c, ax plus by equals c, right? So therefore, from there, you can pretty much just add straight down, right? Make sure you guys negate, do whatever you have to. You already tried the method. If you need extra practice, you can always do the extra practice. Remember, just keep trying until you guys get it. And then from here, pretty much, you get your solution, right? So we go back to getting our solution, which is just an x or an y coordinate, right? So again, I'm going to go over a couple of examples right now to see which is the best method, again, to identify either the equal values, the substitution method, or either using the elimination method, so that therefore we can pretty much move forward from there. So one of the ones that we can do pretty much, let's look at example one right here. And if you guys notice, that's the first thing I want to look for is in which form is it, right? So which form is it? Is each equation in, actually, right? And in this case, if you guys notice, both of these are already in y equals mx plus b form, right? My slope intercept form. All right. So again, the best way for me to either use the equal values or the substitution, right? Also known as a substitution, or I can use elimination. Here, the best case scenario is to use the equal values because both of them are equal to the same thing, right? And we're looking to see where both of these are equal to the exact same value, which in this case could be it's exactly the same x value and it's exactly the same y value. So from here we can move forward. You just set them equal to each other, right? So that'll be 3x plus 11 equals negative 2x plus 1. And then we go ahead and we keep solving for x because that's the variable that's left over. So from here, I add 2x to both sides, right? Draw the line if it helps. That gives us 5x plus 11 equals positive 1. And then from here, subtract 11 from both sides. We end up with 5x equals negative 10. And then here, right, one more step, divide both sides by 5. You guys get x equals negative 2. And that's pretty much my x coordinate for my solution, right? So my solution is always a point. So that's my x coordinate. In this case, negative 2. To find the y coordinate, I go back to either the first original equation or the second one. It doesn't really matter because both of them should be exactly the same value at that x coordinate. So I like the positive one better, so let's substitute x in there. So that's going to be y equals 3 times plus 11, right? So that's the equals method. So that's negative 2. That's what x is. We move forward, we just simplify now. 3 times negative 2 is negative 6 plus 11. Combine those two, you guys get y equals positive 5. So that's my y coordinate. So therefore, that's pretty much my solution right there. All right. So again, remember to box your answers. And that's the first example. The second one, again, I'm going to go over is one that we can use either the substitution elimination method. So right here, we have equals, y plus 3x equals 5, and then y plus 4x equals negative 11. So what we want to do, if you guys notice, both of these are, again, in standard form, right? Standard form is when you have ax plus by equals c, and both of those in this form. Now they look almost like they're in y equals mx plus b form, but if you guys notice, there's a plus right there. The only difference is that here is y is in front, right? And then the y is over here. Now again, remember that makes no difference when you guys are adding numbers. If you have 5 plus 3, that's equal to 8. If you have 3 plus 5, that's still equal to 8, right? So here we can rewrite it so that they end up in the same order. So 3x plus y equals 5. And then the second equation, I'll rewrite it as 4x plus y equals negative 1. So now here, if you guys notice, they're pretty much the y's is an easy candidate for us to eliminate because they have the same number in front of them, right? Both of them have a 1 in front of them. So here, all I have to do is just pretty much multiply one of them by negative 1 to eliminate it, right? Because that's pretty much the method that I'm using. Both of these are in standard form, so I'm going to use elimination. So here, it's either just a preference which equation you guys want to multiply by negative 1. I'll do the top one. So make sure that you guys multiply both sides by negative 1. All right. Always multiply both sides of the equations. Don't forget that. So let me get rid of this line. I'm going to just rewrite it down here. So that's going to be -1 times everything in there. So just everything changes sign. So that's -3x minus y equals, and then again, these two, -5. So this takes me pretty much to my next step, the elimination step, where I just have to add straight down. And I get rid of these two, right? Positive y minus y. Those go away. And then 4x minus 3x leaves you with 1x. And then that's -1 plus -5 gives me -6. And that's my x coordinate. Now, here to find the y coordinate, I pretty much have to think about what I'm going to do with the x value. So I still have to solve for y either way. So again, doesn't matter which equation you guys pick, it should still always give you the same y coordinate. So after this, we want to do pretty much uh, y plus 4 times -6 equals -1. So that's y plus multiply, that gives you -24 equals -1. Add 24 to both sides, you're going to get y equals 23. And that's our y coordinate. So our solution ends up being -6 comma 23.